So in today class, what we'll discuss is first point, definition of heat. Okay, definition of work, similarities between heat and work. Means what is the difference and similarities? Because some factors are in similar, both heat and work are similar in nature, and there are some differences, similarities, and as well as differences. And the last important topic, sign convention. Sign convention. So these are four topics we'll discuss. First is definitions of heat and work. Second is similarities and difference between heat and work, and sign conventions of heat and work. So the sign conventions of heat and work are very important to solve numericals. Otherwise, we will not understand any numericals. This part is important. Okay. First point, heat. Heat will be represented with the letter Q. Okay. And dear students, I will be explaining different similarities at a time and definitions also. Okay. Heat is represented with Q, and the unit of heat is joule. Okay. 1 joule is 1 Newton meter. Keep in mind. Okay. 1 joule is 1 Newton meter. Now, what is the definition of heat is? Both heat and as well as work, both heat and work are energy. If somebody asks you whether heat is a form of energy, you should say yes, heat is a form of energy. Work is also a form of energy. Similarly, potential energy, kinetic energy, chemical energy, etc. Understand? Heat and work also belongs to energy. That is similarities. So what is the definition of heat and work is? Let us consider one system. System is nothing but it is a machine. Okay, one device. And system outside always it is surrounding. So between system and surrounding, it separates with layer that is called as boundary. I hope you remember these three terms: system, boundary, and surrounding. If I say, assume it is a petrol engine. Okay, this petrol engine is moving with some speed, combustion is under process, and the temperature of the system is more compared to surrounding. So assume it is 100 degrees Celsius and here it is 40 degrees Celsius. Just an example, okay? It is not 100, it will be more than 400, 500. So when there is a difference in temperature, of course, it is a common sense that there will be heat transfer, that is Q. So what is the definition of heat is? Heat is, it is a form of energy which transfer or exchange between system and the surrounding by virtue of temperature difference. By virtue of temperature difference. Okay, any energy transfer by virtue of temperature difference, that is purely called as heat. Okay, for example, system velocity is 3 meters per second, or instead of velocity you take pressure 10 bar. Surrounding pressure is 3 bar. If there is a difference in pressure, okay, 10 and 3 bar, so there may be some kind of energy will transfer, because always energy will transfer from high level to low level. So here, due to pressure difference, there is some kind of energy transfer, but I will not call it as heat. You should not call it as heat, because by virtue of temperature difference, if it is there, you should call it as heat, not because of pressure difference. Only energy exchange between system and surrounding pure due to temperature difference, then it is called as heat. Okay, what is definition of heat? Heat is a form of energy which transfer or exchange between system and surrounding by virtue of temperature difference. Understood? So other than temperature difference, there may be exchange of energy, that we will call it as work. Okay, for example, here I told you system having a pressure of 100 bar, okay, and surrounding having a pressure of 40 bar, just an example. And here is the difference in property. Here it is 100 bar, here it is 40 bar. So there is exchange of heat. Okay, not heat, there is exchange of energy. 100 bar to 40 bar, there is a energy will transfer takes place. This condition, you should say it is work transfer, because here we are not concentrating any temperature, we are concentrating on pressure. Okay, instead of pressure, if you seen any energy transfer by virtue of temperature difference, for example, here it is 500 degrees Celsius and here it is 100 degrees Celsius. So by due to this temperature difference, the energy transfer, that you will call it as heat. Any doubts here? When you call it as heat, when you call it as work? Any doubts?
No, sir.
Okay, I will give one example. You categorize, you tell me whether it is work transfer or heat transfer. A person, for example, here is there one man. Okay, his body temperature is 20, let me take it as 40 degrees Celsius, and surrounding temperature, atmospheric temperature, you take it as 20 degrees Celsius. So of course, when there is a difference in property, it may be pressure, temperature, volume, there will be exchange of energy. So this body, this person rejects heat to the surrounding, rejects energy. Okay, dear students, now you tell me what kind of energy is rejected by the body to the surrounding, whether it is work or energy, which kind of energy it is, whether heat or work.
Heat, sir.
Heat, because why it is heat?
Because the temperature is decreasing
Yes,
from 40
temperature.
degree to 20
Yeah,
degree.
yeah. We should say due to temperature difference. Due to temperature difference, if any energy exchange takes place, that is called as heat. Assume is the second case. The second case is same person is doing some mechanical work. He is doing some exercises, but temperature is same. Temperature of the room. The person is sitting inside the room, and the temperature of the room is 20 degrees Celsius, and the person is doing some exercises. In that case, what kind of energy will transfer from person, the body, to the surrounding? Temperature is same,
Work energy.
then it called as work. In the second case, you call it as work. Okay, so that is the difference between work and heat. So very simple definition is energy exchange due to temperature difference, that is called heat. Other than temperature difference, if you see any kind of energy exchange, that we'll call it as work. Simple. Okay, next point. There are two types of work into come into the picture. One is mechanics work, another one is thermodynamic work. They may ask you in the exam, what is the difference between mechanics work and thermodynamics work? Very important. So mechanics works you might have studied in strength of material, mechanics of material. Okay, so what is the formula of work? Work is equal to force into displacement. This is the formula we have studied, I think. So force is N, displacement is nothing but change in length, original length to the change in length. That is what we will call displacement is, I think, but it is in meter. So Newton meter is joule. So unit of work is joule. Keep in mind again. Unit of heat is also joule. Unit of heat is joule, and unit of work is also joule. Okay, I will give an example here. Look at this equation, my dear students. Look at this equation. work done is equal to force into displacement. There are two parameters. One is force, one is displacement. If you take F is equal to 0, what will be the amount of work done? How much will be the work done? F is equal to 0.
Work done is 0.
Work done will be 0. Correct. Simple. Okay. In second case, if you take displacement dl, if it is equal to 0, what will be the work done?
Yes, sir.
Force is there, some force is there, but displacement is 0. Then in the second case also, work done is also 0.
0.
So you mean to say is mechanics engineer, the mechanics engineer, that is strength of material engineer, will say that if the force is 0, work done will be 0. If the displacement is 0, and work done will be 0. But thermodynamic engineer will say that if the displacement is 0, there will be kind of work transfer. Work done will not be 0. If the force is 0, even though there will be some work transfer. I will give an example, simple example I will give. I will not take much time in explaining this thing. So assume that this is a battery, positive node and negative node. So take some wire, one wire, and connect to some resistor, bulb. Okay, connect to some bulb, and you switch on it. Okay, and dear students, I will consider battery is my system. Battery is system, and bulb is here. Bulb ಏನಾಗುತ್ತವಾಗ? This is system. Battery is a system. Anything outside the system you call what you call?
Surrounding.
Surrounding. So resistor, the bulb, okay, you call it as surrounding. Okay, and the battery cover is a boundary. Battery cover, some layer will be there, no, plastic layer. So that is a boundary. Okay. Dear students, when you switch on the battery, is there any movement in the battery? Whether battery will move from one place to another place? Both in the rest condition, it is in room. When you switch on switch, battery is moving. Okay, one place in the inner place ಹೋಗುತ್ತಾ battery switch ಹಾಕಿದ ತಕ್ಷಣ?
No, sir. Power supply.
Okay, only power supply. Very good. Power supply means what? This battery is transferring some energy. Correct or not?
Yes, sir.
Battery, it is transferring some energy. But as you said, the displacement is 0. There is no movement of the system. The device is not moving. The displacement is completely 0. Even though you are saying there is a kind of energy transfer. And here, the temperature of the resistor is also 50 degree. Temperature of the battery is also 50 degree. Assume it is also 50 degrees Celsius. It is also 50 degrees Celsius. So temperature of the surrounding, temperature of the system is same. So when the temperature is same, there is no question of heat. Correct or not? Because always heat transfer, heat exchange takes place due to temperature difference. Temperature difference ಇದ್ರೆ ಮಾತ್ರ heat ಬರುತ್ತೆ, ಇಲ್ಲ ಅಂದ್ರೆ ಇಲ್ಲ. So temperature same ಇದ್ದಾಗ heat ಬರೋದಿಲ್ಲ. So heat ಆಗಲ್ಲ ಅಂದ್ರೆ there must be work transfer. Always keep in mind, either there may be heat transfer or maybe it is work transfer. If the heat transfer is 0, 100% there must be, there should work transfer. If the work transfer is 0, there must be heat transfer. ಯಾವುದಾದರೂ ಒಂದು ಇರಲೇಬೇಕು. If both are 0, that is for isolated system. Isolated system that does not exist. Okay, so here when you do switch on, energy transfer will takes place, some electrons movement and everywhere, the bulb will blow. Okay, so there is no exchange of heat, but there is a exchange of work done, even though displacement is 0. So can you give me any other example how we can elaborate or we can understand this example better? Remove this bulb. I will give best example. One more example I will give. Again, same, take a battery, positive node, negative node. Instead of bulb, you connect one motor. Okay, battery temperature is 50. Again, motor temperature is also 50. Motor temperature is nothing but surrounding temperature. Keep it. This is system. So when you switch on it, when you do switch on and send some batteries in operating condition, so motor will rotate, correct or not? Whether motor starts or not?
Yes, sir. Motor
Yeah.
start.
So when motor starts, what kind of work will you see? Mechanical work, correct or not? Because it is rotation. The motor shaft will be rotating, right? So you'll see that mechanical work. But displacement is zero, no? Displacement of the battery is also zero. So if the displacement is zero, even there is a thermodynamic work will come into the picture. Mechanics work is zero. If the displacement is zero, mechanics work is zero, but thermodynamic work will be there. Keep in mind, this is the difference. They may ask you in the exam. It is simple, only for knowledge point of view I said. So they may ask you definition of thermodynamic work. So how you should say thermodynamic work? Thermodynamic work is a energy transfer between system and surrounding, not due to temperature difference. And when the energy transfer from battery from system to the surrounding, it is equal to raising of weight. Raising weight of weight means there will be some mechanical movement, some reciprocating motion or rotary motion will be there. Okay, that is what thermodynamic work. So thermodynamic work is a energy transfer from system to the surrounding, and it is equal to raising of a weight. Why I'm using raising of a weight? Rising of a weight. Why I'm using this sentence is displacement is zero, but if you fix some motor or if you say fix some engine, so there will be some displacement. Okay, if you fix some motor up and down, there will be some raising and lowering of weight. Okay. That is a definition of thermodynamic work. And formula will be remain same for both. Formula for calculating work done is remain same. So keep in mind, my dear students, it is very important formula. Work done is equal to force into displacement. This is mechanics work. Okay, this formula I will convert into thermodynamic work. Okay, by putting some simple formula. Pressure is equal to force by area. So force is equal to pressure into area. So in this equation, I will substitute it. So work done is equal to, okay. So work done is equal to force. In place of force, I will write pressure into area into displacement. Displacement will be written as dl. Okay, dear students, what is the unit of area? What is the unit of area? Meter
Pi
square.
by 4 d square, sir.
That is a formula. Area is pi by 4 d square. Area unit is meter square, and unit of length is displacement is also length. Okay, displacement is change in length. Okay, increase in length to the original length. That's what you will do. It is meter. So meter square into meter is what? If you multiply these two, what you will get? Meter cube.
Meter cube.
Yeah, meter cube is a unit of what? Simple. Meter cube is a unit of volume. Meter cube is a unit of volume. So in place of these two, I can write P into volume. But here it is a change in length. So I will write change in volume. So this is the formula you must remember for solving numericals. So PdV is there. I will write integration of 1 to 2 PdV. You can ask a question, sir, why is you have written integration? Means the process is flowing from state 1, initial point to final point. So always you will be writing with integration form because it is between two limits. Okay, so once again I will write the formula. You by heart this formula. This is important and you will be remaining for solving all numericals. Let me take the new page. Okay, so what is the basic formula for calculating work done? Work done is equal to integral of 1 to 2 P dV, where P is pressure. So pressure, if the pressure is not given, pressure is equal to force by area. You have to remember this equation. And dV is change in volume. Change in volume. This unit is meter cube. Pressure unit is Newton per meter square. Because unit of force is Newton, area unit is meter square. So it will be Newton per meter square. Now coming back to sign conventions. Okay, it is very important. Sign conventions. And it is easy also. I will give a hint. Okay, sign conventions is nothing but what you call, for example, if the system rejecting heat to the surrounding, whether you will take positive or negative, or the surrounding is supplying heat to the system, whether it is positive or negative, that is what called sign conventions. So sign conventions will be written for both work and as well as heat. Okay, first sign conventions of heat will write. Dear students, important, listen carefully. Here again, system nothing but engine, any device, any machine. If heat is supplied, this is one case. Heat supplied to the system means from the surrounding. Heat is supplied to the system. Second condition is system is rejecting heat to the surrounding. Okay, I will tell you, don't worry, I will write both. Here it is work sign conventions. Sign conventions of work. Again, you take system. Here work done on the system, work done by the system. So we have to write 4 sign conventions here. Heat supplied to the system, that is one. Heat rejected by the system, second one. And on the right hand side, work done on the system and work done by the system. Okay, listen carefully. Work done by the system is always positive. Okay, in the given statement, in the numerical, in the problem, if you give work done by the system is 500 joule, then you should say it is positive value. If you use the word work done on the system or work transfer to the system, in that case, you should take it as negative. On the system is negative, by the system is positive. That is for work. And on the left hand side, it is related to heat. It is exactly opposite, my dear friends. It is opposite. Heat rejected by the system is negative. Heat added to the system is positive. I hope you remember all these 4 sign conventions. Have understood? Will you remember? And
Yes, sir.
okay. Heat added to the system is positive. Heat rejected by the system is negative. Okay, I will give one example. You tell me how much will be the heat transfer, how much will be the work transfer. Let us consider one system. This is a turbine. Turbine is a system. Okay, so this turbine is rejecting heat, that is 200 joule. This turbine is producing some mechanical work, that is thermodynamic work, that is 500 joule. Now you tell me with sign conventions. Nona, who will tell the answer for this question? How much will be the value of Q?
Sir, it is
How much will be the value of work? You apply for sign conventions. Okay, I'm asking you sign conventions. This is 200 joule is heat.
heat is heat.
Yeah, 500 joule is work. So negative
Work.
or positive? Heat 200 joule rejected by the turbine.
It's negative.
Negative. So minus 200 joule you should write. Minus 200 joule. Work is done by the system. 500 joule.
Positive.
Positive. 500 joule. This is how you need to write in the numerical. One more condition. Okay. Let us assume that there is a compressor. There is a compressor. This is a symbol which is okay. Let me erase this. Okay. This is the symbol which is used for compressor. Okay, listen my words carefully. Work supplied to the compressor is 1000 joule. Heat supplied to the compressor is 500 joule. Now you tell me. Work done by the compressor is 0. You tell me how to write sign conventions of heat, sign conventions of work. Other students?
Sir, work is 0.
Work is 0 in one case. Okay, one case the work is 0. Here is also I'm using word 1000 joule work is supplied to the compressor.
Yes, it's positive.
Positive means positive 1000. You should say plus 1000. Okay. 500 joule heat supplied to the compressor. Heat supplied to the system is positive or negative?
Yes, sir. Positive, sir.
Positive. Heat supplied to the system is positive. Here.
Positive.
Okay. Why you said it is 1000 positive? I should know if it is 1000 here work is supplied to the system, positive or negative? Here is also heat is also supplied. Heat is also supplied.
Yeah.
Work is also supplied. There should be some difference, no? Both are supplied to the system and you are saying both are positive, and it should be opposite. Work supplied to the system is positive or negative? Look at this diagram here in the block diagram.
It's negative. Okay.
Work supplied to the system is negative. So this one is wrong. So work should be supplied to the system should be 1000 joule, like this negative. Heat supplied to the system
Positive.
positive 500.
Heat supplied to the system positive.
Positive. Okay, you do not get confused. You remember any one sign conventions. Either you remember the work or remember the heat. And the another one will be opposite. For example, system work done by the system is positive. Work done on the system is negative. This you remember. Exactly opposite for heat. Heat, for example, if the system rejects heat, here it is positive, there you take negative. If system absorb heat, and dear students, some in the exams they may confuse the students. Heat supplied to the system is also same as heat absorbed by the system. Both are same. Understood? I am taking 100 rupees from you. In another word, I am saying you are giving 100 rupees to me. Both are same. Correct. System absorb heat is same as system or surrounding supplied to the heat, supplied to the system. Okay, that is both are same. So here it is positive. Okay, for confusing the students, you will change the statements. Both absorption or supplied same. Any doubts here?
No, sir.
Okay. So in the next in the evening classes, what we'll do is we'll solve numericals. Okay, I will come with some numericals. We'll solve numericals on work and as well as here. So before numericals, let me write the formulas. Okay. So to solve numericals on work transfer, we have to write the formulas for all thermodynamic processes. For example, for isobaric process. Okay. What is a formula for isobaric? Similarly, they may ask you the formula for isochoric process. So to write the formulas for all these isothermal process. Okay, so we will discuss the evening class. We'll discuss the formulas, how to write formula for all these processes. Then we will solve numericals. Similarly, the last one is polytropic. Very easy. Okay, very easy. First, to write the formulas for all these 5 thermodynamic processes, you must remember the basic formula. The basic formula is work done is equal to integration of 1 to 2 TdV. 1 is nothing but it is initial point to final point. So instead of writing initial and final each and every time, always you will be taking initial as 1, final point as 2, PdV. P is pressure, dV is change in volume. Okay, so let me write for first isobaric process. Okay, in 5 minutes. So isobaric means which property remains constant? Which property remains constant here in the isobaric process?
Pressure, sir.
Pressure is
Pressure.
constant. Yeah, bar is a unit of pressure, so pressure is constant here. So P is constant, but dV will not, dV will change. Okay, so work done is equal to P. What is the P is constant? You take outside. Okay, P is constant. No, we'll take outside. P. What is the integration of dV with respect to V? What is the integration of dx? Integration of dx is x. Okay, and you substitute upper limit, lower limit 1 to 2. Okay, so here integration of dv is v. I will substitute lower limit as 1, upper limit as 2. So p into v2 minus v1 is the expression for calculating work done for isobaric process. Okay, so we cannot apply this equation. In the question paper, he said the process is isobaric process, then directly use this equation. Okay, remember expression for work done for isobaric process is 1 to 2. This is equal to P into what is point number 2? Point number 2 is initial or final?
Final, sir.
Final. So volume at the final point minus point number 1 is initial. So volume at initial point. This is the formula. Okay. Could you tell me work done expression for process 3 to 4? Assume that initial point is 3, final point is 4. Using this equation, could you tell me the formula? How to write the formula? This is in general. This is in general. You tell me how to write formula for 3 to 4.
V4 minus V3.
V4 minus V3 multiply by what is that on the left hand side?
P, pressure.
Pressure. Okay. Okay. Always do not think that it is always 1 to 2. No, depends on the process. If the process is 3 to 4 in the given numerical, there may be many processes. Okay, 1 to 2 is one process, 2 to 3 second process, 3 to 4 third process, 4 to 5 fourth process, like that. So if 3 to 4 is isobaric process, in that case, so pressure during the process 3 to 4 and it will be constant, multiply by final volume, that is V4 minus initial volume, that is V3. This is the formula. Okay. Expression for work done for isochoric process. What is isochoric process? Which property remains constant? Isochoric.
Sir, it's volume, sir.
Volume is constant. Means initial volume is same as final volume. Means during the process, the volume of the gas at the beginning of the process, that is initial, is same as volume at the end of the process. So means there is no change in volume. Change in volume, I can write V2 minus V1 is equal to 0. Because V2, for example, V1 is 4 meter cube, V2 is also 4 meter cube, then V2 minus V1 will be equal to 0. So using this equation, what will be the expression for work done for isochoric process? Will you know? Will you get any value or no values? Using same equation, using this equation, to try to reduce it using these conditions. Pressure will be remain same. I will write. What is V2 minus V1? What is V2 minus V1? Here is it. V2 minus V1 is what? What is V2 means? V2 means final minus initial. So V2 minus V1 will be 0. So pressure multiply by 0 will get 0. So work done is 0 for isochoric process. No formula. Okay. In the numerical, calculate work done for the process undergoing isochoric. Directly you write W is equal to 0.